Now let's see the concept of half subtractor. In this half subtractor, that will consist of 4 possible elementary operations. That will be the, if you take 0, 0 minus 0, that will be the difference will be the 0 and the borrow will be the 0, right? If you take the 0 minus 1 means you must have to take the borrow. That means difference will be the 1 with 1 borrow. If you take the 1 minus 0, the difference will be the 1. If you take the 1 minus 1, you will get the 0. This half subtractor is a combinational circuit that subtract 2 bits and produces their difference a minus b. Is a combinational circuit that subtracts 2 bits and produces their difference a minus b. Now let's see the truth table for the half subtractor and as well as the block diagram for the half subtractor as well as the K-map for the half subtractor. And final conclusion will be what will be the disadvantages or the limitations for the half subtractor. Now let's see the truth table for the half subtractor. Truth table. Here, if you take the inputs or if you take the outputs, A, B will be the inputs, difference or borrow. Here this bit is said to be the minute bit and this bit is said to be the subtrahend bit. Two inputs means you will get the 4 output combinations. That will be the 0 0 0 1 1 0 1 1. 0 minus 0, the difference will be the 0. You can't take any borrow, hence the borrow will be the 0. Here 0 minus 1 means difference will be the 1. You must have to take the borrow, right? Then borrow will become the 1. And next 1 minus 0 means difference will be the 1. Here the borrow will be the 0. 1 minus 1 means if you get the difference as 0 and borrow as 0. Now let's take then small example how this subtraction operation will be done in the in this half subtractor. Let's see. Here if you take the 2 bits, that will be the 1 0 minus 0 1. Here this will be in the form of binary numbers. this will be the LSB, and hence this will be the MSB. Here you can see this will become the 2 power 0, and here this will become the 2 power 1. Binary means in terms of in the 2 powers, right? This will be the 2 power 0, and hence this will be the 2 power 1. Here you can see 0 minus 1. You can't subtract, right? Hence you can take the borrow. Here you can take the borrow. This will become the 0. Hence here you will get the 2 power 1 there. 2 power 1 means you will get the 2. Here 2 minus 1 means you will get the output as 1. Okay, here 0 will be there. 0 minus 0, you will get the output as 0. In this way the subtraction operation is happening. Now let's see the block diagram for the half subtractor. Block diagram. This will be the half subtractor. Input be the A, and hence input be the B, and here you will get the difference. Here you will get the borrow. Right, now let's do the K-map for this half subtractor. First you will take for difference here you can see this will be the output as 0 1 1 0. I already told you if you get this output 0 1 1 0, this will be the logical expression for the XOR gate, right, or checkboard configuration. Let's see, this will be the A, B, 0, 1. Here you can take 0 1. This will be the 0 1 2, and here 3, right? If you take 0 0 means 0, 0 1 means 1, 1 0 means 1, 1 1 means 0. This will be the grouping, and hence this will be the A bar, this will be the A. Here this will be the B, this will be the B bar. Here you can see this will become the difference, will become the A bar B plus A B bar. Hence you will get the output as A XOR B. Difference be down. This will be the expression for the K-map for the difference. Let's see for sum. For borrow, right? For borrow. And here now take the K-map for borrow. Here you will get the, this will become the 0 1, sorry, this will become the 0, this will become the 1, and here you will get the A B, right? Here 0 1. Here you can observe 0 1 2 and 3. Here you can see 0 0 means you will get the output as borrow as 0. 0 1 means you will get the borrow as 1. 1 0 means you will get the borrow as 0. 1 1 means you will get the borrow as 0. And this will become the A bar, and hence this will become the A, and this will become the B bar, and this will become the B. Here you can get the A bar borrow will be the A bar B, right? Next we will see the logic diagram for this half subtractor. Logic diagram. That means in this block what will be there, we have to represent it, right, by using this logic diagram. We already get the difference output will be the XOR gate A XOR B, and the for borrow will be the A bar B. Now you can see this will become the XOR gate A B, and here you will get the A bar B, means simply represented by A bar inverter, and here you will get the borrow. This will become the difference, hence this will become the borrow. The main drawbacks or limitations for this half subtractor. Limitations. In the real scenario, we will represented, if you take any half subtractor or full subtractor, we need multi-digits. In multi-digit subtraction is not possible in the half subtractor. That means if you have to subtract 2 bits along with the body of the previous digit subtraction, in that case we require the subtraction of 3 bits. It is not possible in the half subtractor. That means here you can see multi-digit subtraction is not possible. Hence we require or need for the full subtractor. Thank you. In the next class we will see the concept of full subtractor and its truth table and the block diagram, as well as the K-map for the full subtractor, and as well as the logic diagram for the full subtractor. Thank you.